Hello and welcome back to Ganesh Institute and in this series of linear algebra. So what is for today? We are going to discuss how to find an inverse of a matrix using traditional formula. And what is this formula? A inverse is equal to 1 by A determinant adjoint A. I'm hoping that you have already watched that video in which I explained how to find out adjoint and determinant. So we will proceed in the same way. So let's get started.
If we try to find out the inverse of a matrix using conventional formula, that is, the formula is A inverse is equals to 1 by A determinant adjoint A. Now, because in denominator you have this A determinant, so this A determinant cannot be 0, correct? So as to get a finite inverse, okay, a defined inverse, we should say. Now let's apply this formula. You know how to find out adjoint from my previous videos and the determinant also. Let's try with an example. So here's the matrix A: 1 minus 1 0, 2 3 2, minus 2 0 1. Okay, let me write it here also. 1 minus 1 0, 2 3 2, minus 2 0 1. Okay, now let's find out A determinant. So if I use A determinant, if I use first row for A determinant, so I need to write first element, I need to hide first row and first column. What is left? 3 ones are 3, minus 2 0 0, that is 3. Minus sign, because this is the odd place. A 1 2, sum is 1 plus 2, odd. So that's why I need to place minus sign. The element, and then hide the column and row in which it lies. What is left? Minus 1. Then again the element, you need to hide the column and the row in which it lies. So minus 2 ones are 2. So what have you got? 3 ones are 3, plus 2 plus 2 to the 4, that is 9, which is not equal to 0. So which is not equal to 0, so we can go ahead with the inverse. Now the next thing is to find out the minors. Again, let me write the matrix here. So this is your matrix. Need to find out minor. M11, M12, M13, M21, M22, M23, and M31, M32, M33. Okay. So in minors, we don't use element. Just simply, if you, so this is 1 1. Choose 1 1 element and hide the row and column in which it lies and find out the determinant. 3 ones are 3 of the rest of the elements. Then for 1 2, first row, second column, hide this one. So minus 1, right? 1 into minus 1. Minus 1 is the minor. Then for 1 3, first row, third column, minus 2 ones are 2. Okay. Then we have 2 1, hide these two. So 2 ones are 2, minus minus plus 2 to the 4, that is 6. 2 2, hide second row, second column. So 1 ones are 1. 2 3, hide second row, third column. 2 ones are 2. 3 1, hide third row, first column. Determinant of the rest, minus minus plus 3 2s are 6. 3 2, hide third row, second column. Minus of minus 1 into minus 2, that is so this is plus 2 minus 2. then 2, 3. Height, 3, 3. Third row, third column. 3 ones are 3. Minus is in the formula, minus 2. That is plus 2. This becomes 5. So if we've got all the minors, then we need to find out cofactors matrix. Now we know that cofactor, if I need to find out Aij, then this will be minus 1 raised to power I plus j, mij. So only thing which makes cofactors different from minors is the negative or positive sign based on the position. If you take I and j and sum them up, you will see if minus 1 raised to power is odd, then it will make negative cofactor. Minus sign will be there, and if minus 1 raised to power even is there, then there will be no change in sign. Correct? So if I need to write the cofactors, I'll simply write all the minors. 3, minus 1, minus 2. 6, 1, 2. 6, minus 2, 5. Now, because this is a cofactor matrix, Aij, so I'll place opposite sign where all the odd places. Correct? Can you see? If I say this is my matrix A11, A12, A13, A21, A22, A23, A31, A32, A33. When I do I plus j, when will I get odd number? At this place, 1 plus 2 is 3, 2 plus 3 is 5, 3 plus 2 is 5, 2 plus 1 is 3. Rest all are giving us even value. So there will be no change in sign for rest of them. Only this quadrilateral shape will be having opposite sign. That's what I did here. Okay. So we've got cofactor matrix. Now to find out adjoint, what we need? Adjoint is the transpose of cofactors matrix. So convert this row into column. 3, 1, minus 2, minus 6, 1, minus 2, 6, 2, 5. This is adjoint. Now what is A inverse? 1 upon A determinant, adjoint A. A determinant is 9. We've got 9 here, right? Where is it? Here. So if we go ahead, and what is adjoint A? This matrix 3 minus 6, 6, 1, 1, 2, minus 2, minus 2, 5. This is our A inverse. If you want, you can take this 9 in denominator to rest of the elements. This is how we can use traditional method to find out A inverse. If A determinant comes out as 0, that is a singular matrix, then we say inverse does not exist. Okay? Inverse does not exist. Now let's see what other methods are there to find out inverse in our next videos.
If you really like this video, then don't forget to like, share and subscribe our channel. Till my next video, take care of yourself. Bye-bye.